Okay, folks, this is just a simple couple problem from the textbook, and we're just going to discuss a few of the ideas around this idea of a couple. Now, the first thing you need to understand about a couple is that it is two forces that are acting in opposite directions, and the two forces are equal in magnitude and separated by a distance. So it's like a special type of or a pair of moments, really. But you've got a pair of them. Usually with a moment you're dealing with one force. So like we discussed in class, with a moment you have a turning force and we also have a translation. Okay, and we discussed that in class via the idea of a floating boat. So if you don't understand that concept, you might want to look at the video before this one where we discussed that idea. But all you need to know with this is that the first thing that will normally catch you out is you'll use both forces when you're actually answering this question. So you've got to remember the formula for this type of question. So the first thing we'll do is we'll draw ourselves a free body diagram just to make it very, very clear what we're dealing with here. So we can say to ourselves that we have a key and we have a force of 10 newtons acting this way on the free body diagram, because this is a space diagram, which means it's a diagram of the situation with superfluous detail. And over here we're going to draw our free body diagram, which is abbreviated FBD. So you've got 10 newtons acting from one side and 10 newtons acting from another side. Okay, and it's always a good idea to label your forces in your diagram. So we're going to call this F1 and we're going to call this F2. And we're going to prove that this is a couple because we'll say F1 is equal to F2. So they're parallel and they are opposite direction. And they are going to create a turn. So a thing with a couple is it creates a turn without, or rotation without translation. A moment creates rotation with translation. And like I said, the video before this will explain that concept. So we know that this is going to be turning this way, and it's not going to be translating in any other direction. Okay. It doesn't go anywhere else but turn. Okay, so that's what we need to understand about this type of diagram. And we'll just get rid of all this detail here so we don't confuse ourselves. So that's our rotation, and we have our free body diagram. So the next thing we need to use is the formula. The formula is a moment. I'll just get this pen going again. And we might say, get our thicknesses down a bit. The moment of a couple is equal to one of the forces times the distance. Okay, so we need to make sure that we don't use both forces. So if we want to work out the moment of this couple, what we say is moment of couple is equal to 10 newtons multiplied by the distance. Now the distance I forgot to put in my free body diagram, so I didn't complete my free body diagram. So we've got 25 millimeters, and we know that we have to measure our couple in the same units that we measure a moment in, which is Newton meters. So we need to divide by 1,000 because there is 1,000 millimeters in a meter. So we go 1, 2, 3. So we end up with 0.025. So we need to multiply by, put that in here, 0.025 meters is the distance in our free body diagram. So we're going to multiply by 0.025, and that gets us to a moment of couple which is equal to 0.25 Newton meters, and we might just put a direction as well. And that's our answer to our question. So that's the basic example of a couple. Hopefully that's helpful. I will do one more type of question in the next video where we start with our moment of couple and we calculate the force required to create that couple. So just changing the subject of the formula that we're using here. See you in the next video.